Hey guys, I'm so sorry that I can't be there today for class. I just am not feeling well. I'm in a lot of pain today, and so I did not want you to fall behind. So I created this video for you to explain all the problems that you'll be having on your test tomorrow. I know that some of you said that it's difficult not to be able to ask questions. So if you do have any questions today, please just raise your hand and ask Mr. Nolan to stop the video, and either he or someone else in the class can answer the question for you. So don't miss out on that opportunity at all. I want to make sure that you're totally prepared for it. The good news is that you can watch this video again at home if you are studying later tonight. My dog will probably bark at some point in the background. Sorry for that. She's not used to me being home during the day, and all of her dog friends are walking around out back, and so she she has been barking a little bit. So I'll try to minimize that, but in the meantime, hopefully she'll keep quiet for you guys. So the first question asks us to write the numbers in order from least to greatest. If you haven't done this problem yet, go ahead and pause the video and spend a couple minutes doing it, and then I'll explain how to solve it, okay? All right, the first thing that you need to notice in this problem is that it's asking you to do it from least to greatest. So I would put a little note right here that I want it to go smallest number first and my largest number over here. I would do that as a tip or trick because half of the times they might flop it around and do greatest to least or something, and you don't want to get the answer correct in your head but then not put it in the right order and lose all the points after you did a lot of hard work. So that's my first little note. You're going to have a lot more paper than I will, so I might have to erase my work once in a while. But the first number that I want to do is 2 pi, and so I know that's 3.14 times 2, and so I know it's going to be 6 something. So 8 to 6.28. So this is going to be 6.28, and I'm going to erase my work so that I have plenty of space here, but you guys would keep it. The next one I want to do is the square root of 196, and I know that a square root equals two numbers that are the same that equal that 196. And so I know off the top of my head that 12 times 12 equals 144. So I'm going to start there. 13 times 13 then is going to get me 93031. So, nope, I'm doing that wrong. 169. And so I probably can do 14 times 14. That's going to give me the 6. So I know that that's going to be it. So there's 16, 56, 4, 1. There we go, 196. So I know that it is 14 times 14. Okay, so 14 times 14, therefore my square root is 14. And so there's my answer there. All right. And then 4 and 5/8, well, I know it's 4. And 5/8, remember, there she goes. So I know that the whole number is going to be 4. But 5/8, I can change into a decimal. Remember, divide the numerator by the denominator. Plop that in there. And so 8 goes into 5, can't do it, so add that decimal. I know that goes 8 times, and so, nope, it doesn't. I'm lying. I'm thinking 6, sorry about that. 6 times 8 is 48, and then I know it's 20, and so that can go in twice, that's 16, and then if I had more paper here, then I would know I would have 2 left over, 4 left over, which would give me 40, so it's 625. So don't forget that whole number to put back in there. So I know the whole number is 4, but my decimal number was 625. If that didn't make sense because I went a little quickly and I didn't show every single bit of my thinking, please ask to stop the video and they can explain it again. And my last problem here is the cube root of 8. And so cube root, I know it has to be the same number multiplied 3 times in a row that will equal 8. know it's going to be a pretty small number. And so let's try 2. 2 times 2 equals 4, and 4 times 2 equals 8. And so here is my answer. The answer will be 2. So when you're putting all of this together, do not, one of the biggest mistakes is that people give me these answers. Do not give me that. I want the original numbers as they are. I'm starting with the smallest number, and that would be the cube root of 8. And then my next number would be 4 and 5/8, because that starts with a 4 as the whole number. And then 6, oops, I almost did it myself. So be careful of that. The next number is going to be 2 pi. And the last number is the square root of 196. And that's your final answer. Number 2, we talked about on a video a couple of days ago, and we want to compare using greater than, less than, or equal to, or less than, as it's listed here, less than, greater than, or equal to. So we want to find the square root of 12 and the square root of 14. And so in order to find both of these numbers, we have to go with the square root below it. So if 12 is here, that's enough. The square root below it would be 9, and the square root above it would be 16. Here's the interesting thing. The same thing would be true for the square root of 14. Right above it would be 16, and below it would be the square root of 9. So we know, if you think about it, that both of these are going to be 3 point something, because the one below it is 3. And so if this is 3 point something and this is 3 point something, then actually we don't even have to worry about solving these two problems, because this is 3 point something and this is 3 point something. It doesn't matter what those numbers are, because 3 point something plus 14 is going to give us 17 point something, and 3 point something plus 12 is going to give us 15 point something. And so even because both of these start with the same numbers, we don't actually have to solve them all the way. We can just use logic in order to know that 14 plus the square root of 12 is going to be greater than the square root of 14 plus 12. You can pause the video. This is greater. You can pause the video in order to talk that through if you need it, and spend some additional time on it. But that is, I could have gone through the whole process in order to solve it, and found out that this was let's say it was 3.25, and this was, 3.52 or something. Let's just make those numbers up. But really, these are negligible. They don't, they are pretty much the same. And so I'm looking at these add-ins in order to do that. Okay. Now this is a chart that I want you to take a minute to fill out on your own. So pause the video, go ahead and answer this question, and then we'll talk through it. All right. So remember we talked about this chart before, that everything that was inside of another circle belongs to that group, right? And so I like to start with the smallest circle first, because this is the smallest set of numbers. And we talked about that in the beginning. They were whole numbers. And whole numbers are just positive, and they do not have decimals or anything like that. That's it. It's positive numbers like 1, 5, 113, anything like that. But they do not have decimals, they do not have fractions or anything like that. Now, it could be a fraction that would be simplified to be a whole number. That would qualify. But they have to simplify into a positive number that does not have any fractions to it. The second list of numbers that we have are integers, and of course they were the whole numbers and their opposites. So these were positive and negative numbers, and so they include the whole numbers. So if you're an integer, you're also a whole number. Okay, I'm sorry, other way around, other way around, other way around. If you are a whole number, you are also an integer. Okay, so anything, let me clarify that. Anything on the way out, you kind of pick up. Okay, so a whole number will also be an integer, but an integer won't necessarily be a whole number because it has to be positive. Does that make sense? Okay, so it's only on the way out do you collect every other term. Does that kind of make sense to you? So anything on the way out, from the inside out, you collect all those terms and you are also part of that family. Okay, but as you get smaller and smaller, it's a little bit exclusive. You have a smaller circle of friends maybe, and a smaller group that you don't fit into as it goes down. Only on the way out do you collect all those names. You can find other words to say that if you want to pause the video after I'm done explaining and kind of put it in your own words for a friend if they're having trouble with it. So we go from whole numbers to integers to rational numbers, and the rational numbers are the ones that have a fraction now and a decimal. So remember that they are repeated decimals, or they are terminating decimals. They're also fractions, because remember that ratio is in there. So they terminate, they repeat, and they can be written as a fraction. And the last one is real numbers, and real numbers are all of the numbers all together. The only one that we didn't use is irrational numbers. Okay? And irrational numbers are considered real. They just kind of have their own bubble out here. And irrational numbers would be something like pi, or the square root of 7, or something like that, where they're still real, but they're irrational in the sense that they are ongoing decimal numbers that never repeat themselves. So pi, for example. And remember, we talked about the square root of numbers that were not perfect squares. They will go on forever. So they're irrational. And they are considered real, but they do not fit into the other categories. Okay, so if you're whole, you're also an integer and rational and real. If the number is rational, it's rational and real. If you are an integer, you're rational, and you're real. And if you're irrational, then you're just irrational and real. That's it. These two together. So it only works on the way out. If you start where your bubble is and work your way out, you're all of those things to the outside of the circle. That's going to be really important to know, and we're actually going to come back to this diagram. This is something that you just have to memorize. It's something that you just have to understand what qualifies as it in order to be successful on this test. So make sure that you study this part really well and know what qualifies as each type of number. So go ahead and take a minute to look at this problem and pause the video if you need to, and then I'll explain it. So to start this problem, we have to go with the square root of 24, and of course we know that we have to look at the square root above it and the square root below it. So below it is a square root of 16, and above it is a square root of 25. I know that the square root of 16 is 4, and square root of 25 is 5, so I know that this answer is going to be 4 point something. And so I can eliminate 3.9 right off the bat because it's not even within the level of things right here. And looking at these numbers that I have left, I know that 24 is really close to 25, and really far away from 16. And so I don't think it's going to be like halfway through it like 4.67. That's kind of midway between the two of them, a little bit skewed towards the higher end, but this letter A can be eliminated because it's not even going to be close to it. So that leaves me with these two other numbers, and it says which one is a good estimate of the two. They're really, really close in here. I am going to take the 4.9 since it's less math, and I'm going to solve that. I'll pause the video while I do the math for you to save some time. So doing the math for 4.9 times 4.9 in order to find out what that would be squared, I end up with 24.01. It went over, so I know that that can't be my answer. So I honestly don't like this question at all, but because I think that it's actually a pretty decent estimate of it, because if you take 4.89 and you round it, then you'd end up with 4.9. But in this case, make sure you do your math correctly. 4.9 is over it, and so 4.89 would be the correct answer. So your notes for here, it would be don't go over. Okay. Don't go over the square root amount that you have in here. So the square root of 24. If it went over 24, then it's not the correct answer. In this case, I could do the math for 4.89, but I know it's so close to 4.9 that it would be below it, and so that is the best answer out of all of them. So for this problem, it's going to take a lot of patience and a lot of accurate work, okay? And so the first problem I'm going to tackle is the number 1 up here. I'm just trying to see which one of these are true, and you have some answer choices down the bottom. So let me tackle this one first, and let me do 3 pi and see. That seems like really quick for me to be able to solve. So 3.14 times 3, I am at, let's see, 9.42. So this is 9.42, and I know that in order to solve this side of the problem, I've got to look at the square root of 28, go above it and below it, so 25 and 36. And so I know that the square root of 28 has to be 5 point something. Do you agree with that? And so if I take, I don't even have to solve the whole problem. If I take 25 minus 5 point something, I know that I'm going to be at 19 point something. And so if this side is 19 and this side is 9.42, I know that this is not true. So it cannot be letter A. So I don't even have to check number 2 right now. Do you see how the logic works for that? Because I eliminated number 1 as being true, I don't even have to solve it. So I'm getting rid of D as well. It just so happened that I picked a number that allowed me to eliminate a choice. So if you follow the logic of that, I don't even have to work on number 2 at all. I now need to just focus on number 3. And so I know the square root of 44 off of the top of my head, and that equals 12. And so I can just do the math, and I know that 12 times 12 equals 144. So I need to work on 29 minus 8 pi. So I'm going to do 8 pi over here, multiply it times 8, and I end up with 32, 11, 24, 25. So 25.12, and then I'm going to take that number, and I'm going to do 29 minus 25.12, and I don't even have to solve the whole problem. I know, I'll do it anyway, but I know that this is going to be a number like 3 something, right? So it's going to be 8, 8, and it's going to be 3.88. So this side is 3.88, and this side is 12. So 3.88 is less than 12, so this one is true, and so that means that it is only number 3. Because of the answer choices and the way that they gave them to me, and I eliminated answer choice number 1, then I do not even have to solve number 2. I know it's not true. okay? So it's going to be only 3 in this problem. If you take this test smart, you'll be able to eliminate some of these answer choices, but the problem is going to be taking your time on greater than, less than, and also making sure your work is very accurate. I realized in this problem that they didn't even give you a number line. I don't know if you have one on your copy of it, but I do not have one on mine, so sorry about that. You will be given a number line with numbers on it. I don't know why it didn't copy over here, but I would be putting them into decimal form. I will go ahead and create a number line on here for you, and I will solve all these numbers and work through a couple of them on my own, okay? So I did the work on the problem. Obviously, 8/10 is going to equal 8/10. I did the square root of 18 up here, and it became 4.24 after I did some of the work and used our strategies from before and came up with a close estimate of 4.24. For the 5/7, I did the work over on this side over here. And so remember that you take the numerator divided by the denominator, and I ended up with 0.72. I'm sorry, I have my answer wrong here. I wrote it down wrong here. It's 0.72. And then the square root of 4 is 2. And I use the same strategy of going above and below the square root in the for that strategy for finding the square root of 21, and came up with 4.58. So for the number line down here, you're going to see a number line with, I don't know, maybe I don't remember how it actually goes, if it's going to be by halves or by quarters or whatever it happens to be, but let's just say you have a number line like this. What I'm going to be looking for is that you are close to where you should be. So when I'm doing the square root of 4, I want a dot on the 2, and I want it labeled as the square root of 4. Do not label it 2. I want the original number. When you're looking at the square root or 5/7, and it looks like 0.72, well, I know that's going to be between 0.5 and 1, and so it should be kind of in this area right here. And so I want you to put 5/7 above it. I know that 0.8 is greater than that, and so I would be right next to it, and I would have 0.8 labeled for that one as well. So notice, that should be a 0, sorry about that. I want you to be careful with where you put things, whether something's in front of another thing. They should be in the correct general location. But I want you to also use original numbers. Use these guys, not your answer when you simplify it. That's what I'm going to be looking for. Correct general position, where it should be, that they're in number order from lowest to highest, and that you use the original numbers, okay? For problems such as this, it's easiest to just think about it and step back from the problem a little bit and draw a picture. So I know that the area is a square, and that the area is 289 feet squared. And so I need to find the length of the room. And I know that when we find the length of the room, we take the length times the width, and they have to be the same number because it's a square. So essentially what I'm doing is I'm trying to find an unknown value, so x, squared, if I multiply x times x, equals 289 feet squared. And so in order to find the answer to this problem, I need to find out what x is. So in order to find x, I've got to take the square root of x, like saying x times itself equals this number. And so I've got to find out what was the root of that number. Whatever I do to one side, I have to do to the other side. So I have to take the square root of both sides, or the square root of 289 in this case, to find my answer. And so I'm looking for the square root of 289. I already know that 12 times 12 is 144, so I'm going to jump up a little bit higher. Let me try the square root of 16 and see where that puts me. I'm going to do the math. I'll pause the video. And that was 256. So I'm betting that it's actually 17. So I'll do the math for 17 over on the side here. And when I did the math, 17 times 17 equals 289. So each length is 17. Make sure you use your units. So the length of the room is 17 feet. It's not squared. Only the area is squared. The length are individual. Got it? It's just regular feet. All right, the format for this problem really confuses kids for some reason, but we're just looking for x. And in order to find out what x is, we have to find the square root of it. And so essentially all we're asking you to do is to find the square root of one side. In order to find the square root of one side, you have to find the square root of the other side. And we take these as individual numbers. So the square root of, so if I take the square root of x squared, I end up with x. And the square root of 81 is 9. And the square root of 440 is 21. You could do the math on the side, but I'm just going to tell you that it's 21 in this case. So you will be looking for the square root of both sides. Whatever you do to one side, you must do to the other. I need to see this work in order for you to get there. Do not be confused that they're asking you what x is when x was squared over here. In order to get x by itself, you had to take the square root. Okay, so that's your work that you show. If you have to do any math on the side, go ahead and do that as well. But your final answer is going to be 920 over 21. Now the same situation applies to this. In order to find x, I have to take the cube root of it. And so I have to do the same thing to both sides. So I have to ask myself what number times what number times what number, and they all have to be the same, equals 729. And you can guess and check a couple different numbers, of course. Numbers, when you're taking the cube root of something, get big very, very quickly. So don't go do something like 21 or 23 or something like that. Start off small. When you were doing that cube root page that I gave you and the square root page, you should have seen that the numbers got big very, very quick. And if you do some guess and check methods on the side, you're actually going to find out that the square root or the cube root is 9. 9 times 9 times 9 equals 729. So my answer here is going to be x equals 9. There should be no cube root anymore. I want to find out what x is. And so since the cube root is only one of the 9s, then my final answer is 9. Same process, different problem for this one. In order to find out what x is, I need to take the cube root. And so the cube root, if I do it to one side, I have to do it to the other. And so I know that the cube root of x to the third power is just x, because x times x times x equals x cubed. And over here, I need to take the cube root of 27, which is 3. And the cube root of 512, I know it has to be lower than 9 because that was 729, so I do some guess and check methods on the side. And so I would do 8 times 8 times 8, and so that's 64, and 64 times 8 is 32, and it is 512. So it ends up being 3/8 as my final answer. This is very, very important, actually. I'm going to go back to this problem, and I would have lost some credit on it. I just realized that when I did this problem, since I'm taking the square root, I did not put a plus n minus next to it, because if I'm, it can be a positive or a negative here. So I need both of them in order to answer it. Got it? I almost lost credit on that, so don't you do the same thing.